The great deserts of our world are vast, seemingly empty places. They are landscapes sculpted by wind and time where life must be incredibly resilient to survive. But what if we could bring a piece of this extraordinary world into our own home? What if we could witness the daily struggles and triumphs of desert life, all contained within the clear walls of a simple glass jar? This is the grand idea we are embarking upon to create a miniature, self-sustaining desert ecosystem. It is an experiment in patience, a lesson in biology, and a window into one of the most extreme environments on our planet. For the next 100 days, this jar will be a world of its own. Our mission is to build a balanced community of living things. We will select sand, rocks, plants, and perhaps even a few tiny creatures that are perfectly adapted to dry conditions. Each element must be chosen with great care, for in this small, enclosed space, every grain of sand and every drop of water matters immensely. We are not just building a decorative terrarium, we are attempting to replicate the intricate web of life that defines a desert. It is a challenge that requires us to think like nature itself, understanding the needs of each component and how they interact with one another. This jar will become a living laboratory. The journey ahead is one of discovery. We will watch closely as our small world settles and evolves. Will the plants take root and grow? Will the tiny animals find food and shelter? The jar creates a closed system, which means that everything the inhabitants need to survive must be provided from the start, or created within its glass confines. This includes air, water, and nutrients. The cycle of life, death, and decay will play out on a miniature scale right before our eyes. We are about to become the guardians and observers of a tiny, fragile planet. This experiment is more than just a scientific endeavor. It is a way to connect with the natural world on a deeply personal level. It reminds us that life is tenacious, finding ways to thrive in the most unlikely of places. From the scorching heat of the Sahara to the cold, arid plains of the Gobi, life persists. Our little jar is a tribute to that incredible spirit of survival. Over the next 100 days, we hope to learn not only about the mechanics of an ecosystem, but also about the profound beauty and resilience of life itself. Let the grand experiment begin. Every great construction begins with a solid foundation, and our desert world is no different. The very first layer we place in our jar is perhaps the most important, a base of small pebbles and gravel. This layer may seem simple, but it serves a vital purpose. It creates a space for drainage, preventing water from pooling at the bottom and causing the roots of our plants to rot. In a real desert, excess water quickly disappears into the deep, porous ground. Here, in our glass world, these stones will mimic that essential function, creating an underground reservoir that keeps the soil above it healthy and aerated. Above the gravel, we carefully add a thin layer of activated charcoal. This is a special material, full of tiny pores that act like a natural filter. The charcoal will help to keep the air and water inside our sealed jar clean. As organic matter, like a fallen leaf, begins to decay, it can produce odors and harmful substances. The charcoal traps these impurities, preventing them from building up and harming the delicate balance of our ecosystem. It is the silent janitor of our miniature world, working tirelessly to maintain a fresh and healthy environment for all its inhabitants. It is an unseen but crucial element. Now comes the most iconic element of any desert, the sand. We pour in a deep layer of coarse, sandy soil, creating a landscape of gentle dunes and flat plains. This is not just any sand, it is a special mix designed for cacti and succulents, which allows for excellent drainage while holding just enough moisture to support life. This will be the ground in which our plants will anchor their roots, drawing the sparse nutrients they need to grow. The sand is the canvas upon which our desert scene will be painted, the very earth that will sustain our chosen life forms for the journey ahead. Finally, we place a few carefully selected rocks and pieces of wood onto the surface of the sand. These are more than just decoration, they are functional architecture for our desert. The rocks will provide shade from the light, creating cooler microclimates where creatures can escape the midday heat. They offer hiding places, giving a sense of security to any small animals we might introduce. A twisted piece of dried wood adds vertical structure, offering a place to climb and explore. With these foundational elements in place, our empty jar is transformed. It is no longer just glass and sand, it is a landscape waiting for life. A desert is not devoid of life, it is simply home to the most specialized of survivors. For our jar, we must select plants that are masters of water conservation. The first and most obvious choices are succulents. We choose a small echeveria with its beautiful rosette-shaped leaves. These leaves are thick and fleshy for a reason. They are living water tanks. When moisture is available, the plant absorbs it and stores it in its leaves, allowing it to survive for weeks or even months without a single drop of rain. Its waxy coating reduces evaporation, another clever trick for living in a dry world. Next, we introduce a small haworthia, sometimes called a zebra cactus. Its striking white bands make it visually appealing, but its true beauty lies in its hardiness. Like the echeveria, it stores water in its leaves, but it has another fascinating adaptation. In the wild, it often grows partially buried in the sand, with only the tips of its leaves exposed to the harsh sun. This minimizes water loss and protects it from extreme temperatures. In our jar, it will find its own comfortable niche, a perfect example of how plants adapt their behavior to suit their environment. It is a small but mighty survivor. To add a different texture and shape, we plant a piece of living stone, or lithops. This is surely one of nature's most peculiar creations. It looks exactly like two small, smooth pebbles, a brilliant camouflage to avoid being eaten by thirsty animals. Most of the plant lives underground, with only the top surfaces visible. These surfaces have translucent windows that allow sunlight to penetrate deep into the leaf to the photosynthetic cells below. This plant is an expert at hiding in plain sight, and it requires incredibly little water, making it an ideal resident for our sealed ecosystem. It is a master of disguise. Finally, we add a sprig of air plant, or tillandsia, nestled on our piece of driftwood. This plant is an epiphyte, meaning it does not need soil to grow. Instead, it absorbs moisture and nutrients directly from the air through special scales on its leaves. In our closed jar, the humidity that evaporates from the soil will provide the sustenance this unique plant needs. With these 4 green pioneers, our desert now has its producers. They will form the base of the food web, create oxygen, and bring vibrant life to the sandy landscape. Our world is beginning to breathe. With the landscape set and the plants in place, it is time to consider introducing animal life. This is the most delicate decision in our entire experiment. The creatures must be small, require very little food, and be suited to a dry and closed environment. After much consideration, we choose a small colony of springtails. These are tiny, primitive insects, often no bigger than a grain of sand. They are not true desert dwellers, but their role in our sealed ecosystem is absolutely critical. They are nature's cleanup crew, the decomposers who will keep our world healthy and balanced. Springtails are detritivores, which means they feed on decaying organic matter. In our jar, they will feast on any mold that might try to grow, or on any plant leaves that may wither and fall. By eating this material, they break it down and return the nutrients to the soil, making them available for the plants once more. This is the great cycle of life in action. Without these tiny janitors, waste products would build up and our ecosystem would slowly poison itself. They are the humble, unsung heroes who will ensure the long-term viability of our miniature desert. To add a slightly larger and more visible inhabitant, we decide to introduce a few small isopods, often known as pill bugs or roly-polies. We choose a species that is adapted to arid conditions. Like the springtails, these creatures are also decomposers, helping to break down dead plant material and aerate the soil as they burrow. They will find shelter beneath the rocks and in the shade of the succulents, emerging to forage when conditions are right. Watching them navigate the terrain, exploring their small world, will give us a fascinating glimpse into the behavior of desert invertebrates. The introduction of these animals completes our food web, at least in its simplest form. The plants produce organic matter through photosynthesis. When parts of the plants die or if mold appears, the springtails and isopods consume it. Their waste, in turn, fertilizes the soil, providing food for the plants. It is a closed loop, a perfect, miniature recycling system. These tiny creatures are not just residents. They are essential cogs in the machinery of our ecosystem. Their lives, however small, give our jar a heartbeat. The stage is now fully set for our 100-day observation. The moment has arrived. All the components are in place, the layers of stone and sand, the resilient plants, and the tiny animal custodians. Before we seal the lid, there is one final crucial step. We must add water. But how much? Too much, and our desert will become a swamp, rotting the roots of our succulents. Too little, and it will become a sterile wasteland, unable to support life. So we use a small pipette to add just a few milliliters of water, carefully dripping it around the base of each plant. The goal is to make the sand damp but not wet. This initial watering is designed to kickstart the water cycle within the jar. When the light shines on the jar, the temperature inside will rise. This will cause some of the water in the sand to evaporate, turning into water vapor. As the air becomes saturated, or when the temperature drops at night, this vapor will condense on the cool glass walls of the jar. Droplets will form and run down the sides back into the sand, just like a small rain shower. This miniature water cycle is the lifeblood of our sealed world, and we hope it will provide enough moisture to sustain everything inside for the next 100 days. With the water added, we take a deep breath and place the lid on top, sealing it tightly. The clock starts now, day 1 of 100. Our miniature world is now completely on its own, cut off from the outside world. It has everything it needs, or so we hope. It has light from the window, but no more air, water, or food will be added. From this moment on, the fate of the ecosystem rests on the balance we have tried to create. It is a slightly nerve-wracking moment, filled with both anticipation and a sense of great responsibility for the life we have enclosed. We place the jar in a location where it will receive bright, indirect sunlight. Direct sun would be too intense. It could overheat the small glass container and scorch the plants inside, turning our experiment into a tiny oven. The gentle, indirect light will provide the energy the plants need for photosynthesis, without creating extreme temperatures. Now, all we can do is watch and wait. The grand experiment has truly begun. The sealed jar sits silently on the windowsill, a self-contained planet embarking on its long and uncertain journey through time. In the first few days after sealing the jar, the most noticeable change is the daily rhythm of condensation. Each morning, the glass walls are fogged with a fine mist, obscuring the view of the world within. As the day warms up, the fog slowly dissipates, the tiny water droplets evaporating back into the air, only to return as the evening cools. This is a wonderful sign. It tells us that the water cycle is working exactly as we had hoped. The jar is breathing. This rhythmic cycle of evaporation and condensation is the heartbeat of our ecosystem, a constant visual confirmation that the system is active. After about a week, we begin to see subtle signs of life from the plants. The echeveria, which was a little pale after being transplanted, seems to have deepened in color, its leaves looking plumper and more robust. This suggests it has successfully taken up some of the initial water and is settling into its new home. The Haworthia stands tall and proud, its stripes looking sharper than ever. We even notice that one of the lithops, the living stones, appears to have swollen slightly. These are small, almost imperceptible changes, but to the patient observer, they are momentous. They are signs of success, indications that our green survivors are adapting. The animal life is harder to spot. The springtails are so tiny that they are mostly invisible, lost in the texture of the sand. However, by looking very closely near the base of the plants, we can sometimes see the soil shifting ever so slightly, a sign of their tireless work beneath the surface. The isopods are more adventurous. Occasionally we spot one venturing out from under a rock, slowly making its way across the sandy terrain before disappearing into the shade of a succulent. They seem to be exploring their boundaries, mapping out their new territory, and finding the best places to find moisture and shelter. By the end of the third week, a routine has been established. The jar has found its equilibrium. The daily fogging of the glass, the slow, steady greening of the plants, and the occasional sighting of an isopod become familiar sights. There have been no signs of distress, no widespread mold, and no dying plants. This initial period is critical. It is when any major imbalances would likely reveal themselves. The fact that our small world appears stable and healthy is a tremendous relief. It feels less like an experiment now, and more like a living, breathing entity. As we pass the 50-day mark, the halfway point of our journey, the changes within the jar have become more pronounced. The most exciting development is new growth. The echeveria has sent out a tiny new leaf from the center of its rosette, a perfect miniature version of its older siblings. It is a clear and undeniable sign that the plant is not just surviving, but thriving. It is actively growing, using the light from the window and the nutrients in the soil to create new life. This single small leaf feels like a monumental achievement, a testament to the resilience of nature. The behavior of our animal inhabitants has also evolved. We now see the isopods more frequently. They have established clear trails in the sand, between the rocks, and the base of the plants. It seems they have learned where the most humid and food-rich areas are. We even witness a fascinating event, one of the isopods shedding its exoskeleton. It leaves behind a ghostly white shell which is quickly consumed by the springtails and other isopods. Nothing is wasted in this closed system. The old is immediately recycled to create the new, a perfect illustration of the nutrient cycle we had hoped to establish. We also face our first minor challenge. A small patch of white, fuzzy mold appears on the piece of driftwood. In an open environment, this would be of little concern, but in a sealed jar, it could potentially spread and harm the plants. We watch it nervously for a few days, but then, something amazing happens. The springtails, nature's cleaning crew, swarm to the area. Over the next week, we watch as they diligently consume the mold and the patch slowly shrinks until it disappears completely. They have done their job perfectly, managing a potential crisis and restoring balance to the ecosystem without any intervention from us. The overall appearance of the landscape has matured. A thin green film of algae has started to grow on the side of the glass that receives the most light, a natural consequence of light, water, and nutrients. The sand is no longer pristine. It is tracked with the tiny footprints of the isopods and subtly shifted by the burrowing of the springtails. The plants have grown just enough to make the space feel fuller and more established. The jar no longer looks like something we built. It looks like a real wild place in miniature. It has developed its own character, its own unique history written in the sand. As our 100-day experiment draws to a close, we enter a period of intense observation. The ecosystem, now over 3 months old, is a dynamic and ever-changing place. One of the biggest surprises comes from the living stone plant, the lithops. For weeks it had sat perfectly still, looking for all the world like a simple pair of pebbles. Then one morning, we notice a tiny fissure appearing between its 2 leaves. Over the next few days, a delicate daisy-like yellow flower emerges from the center. It is an utterly unexpected and breathtaking sight, a burst of vibrant color in our muted desert world. The flower is a sign of a supremely happy plant, one that has not only survived but has gathered enough energy to reproduce. It is the ultimate confirmation that the conditions inside the jar are favorable. The flower only lasts for a few days before it begins to wither. And once again, the tireless cleanup crew moves in. The springtails and isopods begin to break down the decaying petals, ensuring that the valuable nutrients locked within the flower are returned to the soil. It is a beautiful, complete cycle of life, growth, reproduction, and decay, all happening on a timescale we can witness. Not all the changes are so spectacular. We notice that one of the older outer leaves of the echeveria has started to shrivel and dry up. This is not a sign of sickness, but a natural part of the plant's life cycle. As it produces new leaves in the center, it sheds its old ones. The dried leaf eventually falls onto the sand. It lies there for a few days before the isopods begin to nibble at its edges, slowly breaking it apart. This simple event beautifully illustrates the slow, constant turnover of resources within our sealed world. Nothing is ever truly lost, it is just transformed. In these final weeks, the balance feels more robust than ever. The daily condensation cycle continues its faithful rhythm. The plants look strong, displaying new growth that balances out the natural loss of old leaves. The animal populations appear stable, their activity a familiar and comforting sight. The jar has become a testament to the power of a well-designed system. It has weathered minor challenges and produced moments of surprising beauty. As we approach day 100, we feel a sense of pride and wonder at what has unfolded within this simple glass container. Today is day 100. Our experiment is complete. We look at the small glass jar, this world we created, and reflect on its journey. The ecosystem has not just survived, it has flourished. The plants are larger and more numerous than when we started. The isopods and springtails are active, their populations stable. The water cycle, the nutrient cycle, and the food web all appear to be functioning in perfect harmony. Life can indeed survive and even thrive in such a small, closed space, provided the initial balance is correct. It is a powerful lesson in the principles of ecology. This journey has taught us so much about the resilience of life, we have seen how desert plants, with their incredible adaptations for storing water and reducing evaporation, are true masters of survival. We have witnessed the vital, often overlooked role of decomposers like springtails and isopods in keeping an environment clean and recycling nutrients. They are the humble foundation upon which all ecosystems are built. The surprise bloom of the lithops flower was a joyful reminder that nature is full of unexpected beauty, and that even in the harshest conditions, life strives not just to exist, but to celebrate itself. Our little jar is a microcosm of our own planet. It is a closed system, reliant on a delicate balance of resources. It shows us how every component, from the mightiest plant to the tiniest insect, has a crucial role to play. If one part of the system fails, the whole community is affected. The health of our jar depended on the interplay between water, light, plants, and animals. In the same way, the health of planet Earth depends on the intricate connections between our oceans, forests, atmosphere, and all the living creatures that inhabit them. It is a profound responsibility. This experiment began as a simple question. Could we create a world in a jar? 100 days later, we have our answer. But we have gained something far more valuable than that. We have gained a deeper appreciation for the complexity and fragility of the natural world. It inspires us to look closer, to notice the small wonders around us, and to understand that we are all part of a grand, interconnected ecosystem. And it leaves us with a hopeful message that by understanding and respecting the principles of nature, we can help to support and nurture life, wherever we may find it.